Hi everyone, welcome to Math Learning Hub, a hub for everybody who loves math. So today I'll be teaching you how to count the number of ways to rearrange the letters in a specific word. And so I guess we'll just jump in with an example, for example, blemish. So for the word blemish, you can see I have some written possibilities here. And these are basically ways of rearranging the letters in this word, and we have to figure out how many ways we can do this, right? Okay, so as you can see that I've written in orange, blemish has 7 letters, right? And the letters are all different. And so what we're gonna do here is that we're actually gonna draw 7 blanks here, as I've done. And what we're doing here is each blank essentially represents a slot for a letter, right? So for example, this first blank would be the slot for the first letter. Second here would be the slot for the second letter. The third blank would be the slot for the third letter. I think you get the idea. And so we're just going to go through one by one and see how many letter possibilities are there for each blank, okay? So let's start for the first blank here. First blank, well, how many letters do we have? How many options do we have to place in the first blank, right? So we have 7 letters. We have 7 letters. So that means we have 7 options to place for the first letter, right? Okay, and so now let's move to the second letter, right? The second letter over here. How many letter options do we have left for the second letter, right? How many do we have left? So let's suppose for this first letter, I used the M, right? I used the M. So for the second letter, I can use any letter except for the M because I've used the M already. So that means I have 7 minus 1, which is 6 options left, okay? 6 options for the second letter. Okay. For the third letter, how many options do I have? So let's suppose that I use the I for the second letter. So for the third letter, how many letters do I have left? So 1, 2, 3, 4, 5, right? We have 5 options for the third letter. Let me write that better. 5. And then for the fourth letter, how many options do we still have? So let's say I use the B for the third letter. So for the fourth letter, I have 1, 2, 3, 4 options left. Only 4 options left. And you can see where this is going here, right? So this is going to be 3 options left for the fifth letter, 2 options left for the sixth letter, and only 1 option left for the seventh letter, right? As the number of ways to rearrange these letters is basically all of these values multiplied together. So it's basically 7 times 6 times 5 times 4 times 3 times 2 times 1, right? I'm just going to write these times symbols. And that is just going to be equal to 5040, right? Or 5040, right? And then now I would like to introduce you to a concept called factorials, right? Factorials. So factorials are basically when you take a number and you multiply it by all the consecutive numbers below it. For example, 4 factorial is equal to 4 times 3 times 2 times 1. 7 factorial is equal to 7 times 6 times 5 times 4 times 3 times 2 times 1. And that's exactly what we have here. So in general, using this logic for any given word with distinct letters, the number of ways to rearrange the letters in the word is basically n factorial for a word with n distinct letters. And so you notice I'm making this distinction about this word distinct here, no pun intended, but there is a reason for this. And we'll just look at this with our second example, banana. So how many ways are there to rearrange the letters in the word banana, right? So let's see here. So at first glance, you might think, well, how many letters are there in banana? So it's 1, 2, 3, 4, 5, 6 letters in banana. So you might think it's just 6 factorial, right? However, that is actually overcounting. For example, if you have, for example, A, N, A, N, A, B, and you swap these two A's, this solution doesn't account for the fact that it's the same word. So it overcounts, right? It overcounts. So how do we fix this overcounting, right? Well, you have to divide by something, right? So what do you divide by, right? So let's think about this. So you have your 6 factorial initial count, not considering duplicate letters such as A or N, right? And then so what we do to account for these duplicate letters is we divide by the number of ways to rearrange those specific letters. So let's look at the A's, right? So how many A's do we have? We have 3 A's, right? And how many ways can we rearrange those A's, right? Well, using our n factorial formula over here, that's just going to be 3 factorial, right? Remember, this is 3 times 2 times 1. And you can see this if you use the same logic we did here. So there's 3 for the first blank, 2 for the second blank, and 1 for the last blank, and you multiply them all together, right? And then now let's look at the ends, So how many ways are there to rearrange the ends? Well, since there is 1, 2 ends, that's just 2 factorial from this n factorial over here. That's 2 times 1, right? So this denominator over here actually accounts for the overcounting for the specific letter, right? And then so let's work this out, right? So 6 factorial, we can write this as 6 times 5 times 4 times 3 factorial, right? 3 factorial is 3 times 2 times 1. And you might ask, why are you writing this as 3 factorial? You'll find out in just a second. And you divide by 3 factorial. I'm just going to keep it in this form. But if you're confused, just write out 3 times 2 times 1, and then times 2, right? 2 factorial is 2 times 1. Of course, we don't really need to worry about the 1 here since it won't really change our answer. And so we're just evaluating this expression here. We notice that you can cancel these 3 factorials, right? So writing out your factorials in this way can actually help you cancel and make your job a little bit easier. And then you can cancel the denominator with the numerator as well, because they have a common factor of 2. And you get that there are 60 ways to rearrange the letters in the word banana. So in conclusion, what we learned in this video is basically the number of ways to rearrange the letters, and a word with n distinct letters is n factorial, where a factorial is basically when you take a number and you multiply it by all the numbers below it. The number of ways to rearrange the letters in a word that has non-distinct letters, on the other hand, such as the word banana, which has duplicate A's and N's, you just take the number of total letters you have, factorial, and you divide it by the number of ways to arrange the duplicate letters. So in this case, it would be 6 factorial divided by 3 factorial and 2 factorial. So that is it for this video. If you have any questions, then feel free to comment below. And thank you so much for watching. See you in the next one. Bye.